Our shortcut for writing repeated multiplication. Okay, you have your base, which is the number on the bottom, and you have your exponent, which is a small number. And what the exponent tells you is how many times you multiply that base. Okay, this is not 5 times 3. Okay, this is 5 times 5 3 times. So 5 times 5 times 5, so it's 125. Okay, so 4 to the third is 4 times 4 times 4. So that's 16 times 4, so that's 64. 2 to the 8th is 2 times 2 times 2 times 2. Okay, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128, times 2 is 256. Exponents get really large really fast, right? We have 8 2's, that's 256. It's known as exponential growth. If you ever hear that term, exponential growth means things are growing like at a really fast rate like that. Common bases mean matching bases. Okay. And to multiply exponents with common base, you add the exponents. And the base does not change. Okay, so x to the third times x to the fifth is x, and you're going to add 3 and 5, so that's x to the 8th. 4 to the 12th times 4 to the third, you do 12 plus 3, so you get 4 to the 15th. X to the 4th times y to the 10th, those are not common bases. So I really can't do anything with it. It stays the same. And here I have x to the 6th times y to the 9th times x to the 3rd. These are common. So I can do x to the 3 plus 6, and then y to the 9th will stay the same. So that becomes x to the 9th, y to the 9th. Okay, when you're dividing, again, it has to be common bases, and you subtract the exponents. Okay, so x to the 13th over x to the 8th is 13 minus 8. So you subtract the bottom from the top. So that's x to the 5th. This is a to the 8 minus 5. So that's a to the 3rd. Now, negative exponents. Okay, negative exponents aren't allowed except in scientific notation. So here's what's going to happen. I have 5 minus 15. That's negative 10. I'm not allowed to have a negative 10. So when that happens, I have to take the reciprocal. Or you can look at it this way. I'm going to subtract whichever one is smaller from whichever one is larger. 5 is smaller than 15, so I'm going to subtract 5 from 15, and 15 was bigger, so it kind of wins the tug of war as to which side you're on. So I could have gone straight from here and said y to the 10th in the bottom.
Like if there's a small number above the larger one, then you just do it
On the
reciprocal.
Yeah. So you just put it in the bottom. So like the larger number wins, and so it stays in the bottom. When you have multi-step, multiplication and division, I look at each part separately. I don't want red. So basically, essentially, what I do is I break it into parts. You don't have to rewrite it like this. I'm just showing you how I'm looking at it. Okay, 48 divided by 8 is 6. 8 minus 5 is 3. 16 minus 9 is 7. And then here I've got the 7 in the bottom, so 7 minus 2 is 5. Oh, wait a second. When you're multiplying, you look at each part kind of separately. So this is like 3 times 5, and then the x's times each other, the y's times each other, and the z's times each other. Again, you don't have to write all this out. It's just what you're doing is putting the things that match together. So 3 times 5 is 15. X to the 5th times x to the 3rd, I add those exponents. So I get x to the 8th. Y to the 6th and y to the 3rd, I add the exponents to get to the 9th. And z squared and z to the 5th gives me z to the 7th. So each part goes with what it matches. Now when you have both, we have multiplication and division. We need to do the multiplication first and then do the division. So I'm going to do 2 times 9 to get 18. X to the 3rd times x to the 4th. That's going to give me x to the 7th. And then y squared and y to the 5th is going to give me y to the 7th. And so far the denominator stayed the same because there was nothing to do down there. Now I do the division. So 18 divided by 3 is 6. 7, x to the 7th over x to the 3rd, I'm going to subtract, so I get x to the 4th. And y to the 7th over y to the 12th, the 12 is bigger, so it'll be in the denominator. For a second. Okay, when I have a situation like this, x to the 7th over x to the 6th, that's x to the 1. But we don't really write an exponent of 1. Okay, so anytime you get x to the 1, it's just x, or anything to the 1 is just itself, because that literally means you have 1 x. So you just write x, right? Now, x to the 3rd over x to the 3rd, that's 3 minus 3, so that's x to the 0, which literally means I have no x's. But what do we do with it? If you think about it this way, x to the 3rd is 3 x's, right? What's x divided by x? And x divided by x is 1, and x divided by x is 1. And 1 times 1 times 1 equals 1. So any exponent to the power of 0, or I'm sorry, any base to the power of 0 is always going to be 1. So that's any number. Okay, so anytime you get an exponent that's 0, you just write 1. So exponent of 1 goes away, exponents of 0 give you a 1. Okay, if when we multiply two exponents together, we add them. If we're going to raise a power to a power, we multiply the exponents. Okay, and here's why. Okay, I'm not going to use it with this one. We'll do a smaller example. Okay, if I do x to the third squared, that's the same thing as x to the third times x to the third, which is x to the sixth, right? Because I'd add the two. You know, if you square something, you multiply it by itself, but then you'd add the exponents, and so you get x to the sixth. Or I could skip this whole step and just say 3 times 2 is 6. Right? So do I want to write out x to the fifth 7 times and then add all the 5s together? No. I want to say 5 times 7 is 35. Or 3 times 6 is 18. And when you have more than one object inside the parentheses that you're raising to a power, it's almost like distribution. I have to take the 2 to the third, and I have to take the x to the fourth to the third. So this becomes 2 to the third, and then x to the 4 times 3. So it would be 8x to the 12th. And if I have a lot of things, I do the same thing to each. Every single thing inside has to be squared. So 6 squared is 36. Yeah.
On the 2x to the 4th
Mm-hmm.
times 3, how'd you get 8?
2 to the third is 2 times 2 times 2. So 6 squared is 36. And then I do x squared, so it's 2 times 2, so that's x to the fourth. And then y is 11. So 11 times 2 is 22. And then z is 5, so 5 times 2 is 10. It's essentially just a shortcut. Again, we do a lot of shortcuts. It's a shortcut for writing long numbers, and that's either like a very large number or an exceedingly small number, which is like a very long decimal. Okay, and we use powers of 10. And the reason we use powers of 10 because if you multiply things by powers of 10, all you're doing is moving decimals. Okay, so to go from a large number to a scientific notation, we're going to count the places. To the, hold on. Okay, so we're going to move the decimal. And right now the decimal is here at the end of the number. And we want to go here, right after the very first digit. And we're going to count how many places there are. So we go, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 places. Okay. Now, we only want 2 decimal places. So we're going to take this portion right here, and we're going to turn that into 2.56. Now, if this had been like a 5 or 7 or something, we would have made it 2.57. We would have rounded, but because it was a 3, it stayed 2.56. You're always going to do times 10. And this is your exponent on the 10. So 14. Again, I want my decimal right here after the first number, so I'm going to start counting. There's 22 places. Now this 5 right here is going to round that 2 to a 3. Oops, sorry. So I'm going to be 4.83 instead of 4.82. And then I counted 22 places, so it's times 10 to the 22nd. So, as you can see, it's much nicer to write 4.9 times 10 to the 36 than to write that big old long number. Which, let's see, thousands, millions, billions. Quintillions, septillions, sextillions, septillions. Oh man, hold on. Okay, millions, billions, trillions, quintillions, quadrillions, quintillions, sextillions, septillions, octillions, nonillions. I don't remember 10. Yeah, okay, so right here we're at nonillions. So this is like 325 nonillion. I don't remember what these two are because, well, who uses these numbers? So, okay. All right, from a really small number, so decimal, is the same process, but with a negative exponent. These are the only times that negative exponents are allowed. We want it after the first non-zero number. So the first number that's not a 0 is where you want to move your decimal to. Okay, so then I start counting from the decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 places. So this is going to be 3.28 because again we only want 2 decimal places times 10 to the negative 13. Okay, so we're going to start here. That's 23 places. Okay, I want these 3 numbers. It's not going to round again because the 1 is not too big. So that's going to be 4.58 times 10 to the negative 23.
So if the number, like say the number after 8 would have been like 6, you would have
Rounded to a 9. Mm-hmm. Okay, that's 25, I think. Hold on, let me recount that.
I counted 25.
Okay, 25 places. Thank you. And in this instance, we are going to round because if I take these 3 digits, this 8 is going to round that 5. So I'm going to have 1.26 times 10 to the negative 25th. Okay. If you have a positive exponent, this is how many places you are going to need to add. Well, but moving the decimal first. So here's what I do. I write down the first number. And then I start counting to 9. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So these 3 decimal places take up 3 of those 9, and then I have to add 6 zeros. Okay. I'm going to skip down to this one, which is also positive. I'm going to do the same thing. I start out, I go 5, I just write the 5. I have to count to 17, so I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 2 decimal places, 15 zeros to add up to 17. It's a little different. What I do is I start over here. Actually, stop that. I write what's after the decimal, and then I start counting with the first number, and I go backwards. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So it's 10 zeros.
10 zeros. Or you can look at this and say, okay, this is -7. That's 1 decimal place, so I'm going to have to do 6 zeros. And then add the number that's there. It depends on how you like to look at it. Just remember that this is not the number of zeros. This is the number of total places that you're moving, so you have to take into account the decimals that are there. If it's negative, it's only going to be 1. Usually. If it's positive, you could have 2 or 3, but you have to deduct from the exponent.